I want to greet everyone. It's so great to see you, the familiar faces, and just thank you for coming to share this information in this session with us. I'm super excited to talk to you about what's happening in the School of Medicine and at Atrium Health Wake Forest Baptist as we integrate with Advocate Health, and I'll talk a little bit about that. But then also to share with you some of these amazing research that we have going on so you can see how we're really shaping the future, moving medicine forward. Have that title. So I have some slides here. I'm not going to go into such great detail on them, but I would say that one of the things you should know about our school, the Wake Forest University School of Medicine, the former Bowman Gray School of Medicine, is that we are integrating, we're innovating, and we're making an impact. So we're spending a lot of time becoming integrated, fully integrated into one of the largest health systems in the country, which is Advocate Health. And as that is happening, we're really innovating to create some real breadth and scope for our school in a way that has never been done and is not being done anywhere else in the nation. And as a result, we're in the process of really creating truly the most impactful, what we call learning health system in the country, because we are part of a large health system, but our medical school really fuels the learning so that we make sure the discoveries get to patients as quickly as possible through not only our training of the best healthcare professionals, but also by doing that best research that we make sure gets into the hands of as many people as possible. So one of the things I just want to review is, as Lisa mentioned, I came in 2023. Has it been that long? 2.5 years. Just prior to when I came, Wake Forest University School of Medicine and Atrium Health became Advocate Health. And at that point, when I entered as dean, we were actually just breaking ground on the Charlotte campus. That was my first day. It was a big press gaggle and all these dignitaries and everything there, and I was scared as anything, but I made it through. I made it through. They gave me a written script, so that helped. I said, just read. I can still read. And we started on a journey of one school with 2 campuses and beyond. So being, an outstanding, distinguished medical school, one of the few in the nation, particularly a private place, that would have more than one campus, and then the opportunity to really extend and expand beyond our scope. So it's really been such a transformative time period for the school as we join this very large health system, and we integrate with our clinical programs, with our research, and with our education. This is just a little bit. We always talk about the Advocate Health, but I wonder if people really know much about Advocate because we don't have very much branding about it. It's kind of below the radar. So I thought I'd just put up a slide here first, that Advocate Health is the second largest health system in the country with an integrated medical school. So the Wake Forest University School of Medicine is fully integrated with Advocate Health. And there's only one other large health system in the country like that. And then we're the third largest not-for-profit health system in the country. There's a lot of community benefit dollars. This system really cares about caring for all and really investing in communities across the nation. So $6 billion going to community benefit each year. I think it's the highest invested in the nation. Over 162,000 folks work. 6 million patients are in the Advocate Health system. And that's across multiple states. So that's North Carolina, South Carolina, Georgia, a little bit of Alabama, Wisconsin, and Illinois. So we've got over 70 hospitals, over thousands and thousands of care locations, virtual care platforms, hospital at home, lots of really innovative things that are happening in Advocate Health that are helping us really advance our mission of discovery and excellence in education. As you know, I talked a little bit about the Charlotte campus. Really super excited because the Charlotte campus is opening in June. So we're going to be doing a ribbon cutting in June. We've got our first 48 medical students entering the medical school class in June. And that'll be our journey towards a class that'll be 100 students per class coming in Charlotte. So we already have 1,000 faculty members that have been teaching students and are excited to welcome the new students. And we have that white coat ceremony, which is when we welcome the new potential docs in, and we're going to have our first white coat ceremony in Charlotte in July, excuse me. So super super duper exciting there. And I can't tell you how excited the community is there. At the same time, we're continuing to build here in Winston-Salem with all kinds of programs and investments that we're doing. I'm going to skip over this a little bit just to say, oh, I wanted to get to a certain slide. I can't go too fast. I talked about the faculty. All right, I'm ahead of myself. Let me back up a little bit. We'll start here. One of the things I want to say about Advocate, which is really important, is that there's something called Rewire 2030, which is the strategic plan for Advocate. It's how this organization is rewiring itself. And the slide that I wanted to have, there was another piece on there that said, one of the things Advocate has committed to is becoming a national academic model. And Wake Forest University School of Medicine is the core of for the academics throughout all of Advocate. So that's really important to recognize that as we have joined with a very large health system, that very large health system recognizes Wake Forest University School of Medicine as being special, an important part of the success of the organization. And that's really, really rare for a very large corporation to say, hey, we want to be a national academic model. It speaks to the importance of the organization to the educational mission and training our most outstanding clinicians, and also the excellence, the investment in our research and our discovery enterprise. So there's really a very positive thing for our school to be integrated, and our health system to be integrated with this large national health system. We have now thousands of faculty. We've got over 2,000 in Winston-Salem and over 1,000 in Charlotte, and we're actually extending faculty appointments even beyond those two campuses to folks who are doing teaching and research in Wisconsin and Illinois, so that's very exciting. We have over 160 folks that have applied for and going through the process to become faculty, Wake Forest faculty, and they're split between our basic science. Our basic science campus is the vast majority of our basic science is done here in Winston-Salem, and we continue to grow that program, and then our clinical faculty is spread across both campuses. This is what I wanted to get to. We've recruited 48 new faculty members that came as a result of resources that came with the initial Atrium merger. And the vast majority of those 48 new faculty members are right here in Winston-Salem. So it just shows how we're really growing the Winston-Salem research and faculty footprint. We can continue to invest here. We continue to grow our mission here in Winston-Salem, which is important, as we also grow in Charlotte. And those faculty are working in all kinds of areas, aging and mobility, heart and vascular, Alzheimer's disease, neurosciences, a whole slew of areas that are very cutting edge, that our faculty are really out front on, and we're excited to have invested and put real resources behind these areas. The school is growing in its research. We've got 18 research centers that do research all the way from vaccines in children to how to deal with aging and Alzheimer's across the full spectrum. The 8 areas of focus, some of the ones that I told you, which include cancer, the regenerative medicine, aging, number of areas that we actually focus our research around. And then we really focus on pairing our research with the clinical enterprise. In 3 specific areas that the clinical enterprise, Advocate Health, has said we want to become national leaders in: the study of heart and vasculature, neurosciences, and cancer. We're making sure that all of our education, research, and clinical trials programs are right there, very tightly aligned with those programs. So we really have that learning health system concept where the teaching, the education, and the research are side by side with the clinical care that we're delivering to individuals who come into our walls. We also have some new departments and centers. Some of it is focused on the neurosciences, so how does the brain work? Very much focused on those areas, all the way from looking at mechanisms in the laboratory, all the way to clinical trials and care in the clinic. We have a new eye center, a new translational research eye center. Now, today we broke ground on a new eye institute for Atrium Health Wake Forest Baptist. We're really thrilled. It's going to be on Vine Street. It's a beautiful area. I just had a groundbreaking, but it was like I had the sledgehammer, yeah. I never held one of those before. It's pretty heavy. And to hit the wall, We just did a wall breaking of the new Eye Institute. Well, what's great about that is we also have a new research center that's focused on vision. And so we really are going to have one of the nation's truly best centers for care of eye diseases and vision. We also have a big focus on AI. I know you hear about AI a lot and how it's changing things. We have a new Center for AI Research led by Dr. Metin Gurkin, doing all kinds of exciting research on how to improve healthcare, how to speed the rate at which we make discoveries. So we're really at the cutting edge with that. And then we're doing work to understand how can we take care of people better even outside of our walls. We have a new center for remote monitoring. So you know all the wearables that we have, people have things on your wrists, you can check your heart. You can actually get a lot of care outside of the home. So we have a whole center focused on remote monitoring and remote health. And soon Advocate Health will have one of the largest virtual healthcare platforms in the country. So they're going to be able to get access very quickly to a primary care physician without even going into the clinic. So you can get that first access. So there's a lot of this work that modernizes medicine and brings technology in for the better into our spaces. Our research funding has grown. 5 years ago, we had half of the amount of research that we have now. And that's in large part to outstanding scientists like the ones who are going to be presenting to you tonight. The Dean's Research Scholars are really hotshot, heavy hitter researchers doing cutting edge work, and they're bringing in lots of grant funding because their work is so impactful and important. Other things just to mention is that we have a National Center for Clinical Trials that we're going to be doing in Advocate, so that Advocate with all of those varying hospitals, 70 hospitals and all these thousands of care locations, one of the things we want to do is make sure that we have clinical trials that everybody can be a part of throughout all of Advocate. And why is that important? If you've had a condition, hopefully not like cancer, if you have a disease like that and you go in, you want to be a part of a clinical trial, because a clinical trial offers you the opportunity of either getting the current standard of care or potentially the next best treatment, which could be a cure. So clinical trials are considered one of the best ways to get people the most advanced care in the context. And so we want to be able to offer people clinical trials throughout all of our healthcare system. And one of the things our school is doing is creating that platform through something called the Advocate Center for National Center for Clinical Trials, powered by the Wake Forest University School of Medicine. So our scientists and researchers are key to making this happen and bringing all the excellence so that we can do clinical trials throughout Advocate Health. And I mentioned a little bit about pairing the clinical trials with the clinical care. I'm going quickly because what I want to do is get to this exciting program that we have, which is really to talk about, to have you hear about the outstanding research that we have. And so tonight, we're going to be, 3 of our outstanding researchers are going to present to you, and I'm going to be introducing them to you right now. They are part of 3 of our 6 inaugural Dean's Research Scholars. These Dean's Research Scholars were chosen by the Dean's office, my office, because of their outstanding work. They're truly doing cutting edge, important, impactful work that affects not only our community, but also the nation and beyond. They are really those up-and-coming folks that we have invested in. We want to make sure that they have even more success, so that they were awarded this, have received some supplemental resources for their research. They want to engage in periodic networking events like this so that you can hear about their work, you can hear what's happening in medicine and beyond, and share the excitement. So tonight I'm going to be 3 of our Dean's Research Scholars are going to be coming up. I'm going to introduce them now, and then they're going to successively come up and give their presentation, and then we'll have some questions and answers at the end. So I'd like to welcome Drs. Tao Ma, Kristina Henderson-Lewis, and Timothy Hughes. Dr. Tao Ma is a professor in the Department of Internal Medicine, Gerontology, and Geriatric Medicine, in the Department of Neurosciences Center of Healthy Aging and Alzheimer's Prevention. He's in a lot of different places. He is a professor with tenure at Wake Forest University School of Medicine. He's a neuroscientist studying the way that the brain works and other areas with a specialization in cognitive function under physiological and pathological conditions. The focus of his laboratory is to investigate novel molecular mechanisms underlying the way that the things that cause Alzheimer's disease and Down syndrome, and then looking for those therapies. How can we treat these conditions? He uses a number of techniques in his lab, and so it'll be exciting to hear about his work and some of those advanced techniques that he's using to study those areas. Then we'll move to Dr. Kristin Henderson-Lewis, an associate professor in the Department of Epidemiology and Prevention, who earned her undergraduate degree from Duke University and her other degree from Tulane University. After medical school, she completed an internal medicine residency at the Mass General Hospital, followed by General Internal Medicine Fellowship at Harvard Medical School, during which time she also earned a Master's of Science degree in Health Policy and Management from the Harvard School of Public Health. She is a board certified in both internal medicine and obesity medicine, and currently sits on the board of directors of the American Board of Obesity Medicine. She's published over 50 peer-reviewed articles on the prevention and treatment of obesity, including many prestigious journals, such as the New England Journal of Medicine. And she served as the principal investigator or co-investigator on many, many NIH research funded, as well as research funded through foundations. Dr. Timothy Hughes will be next, and he's an associate professor in the Department of Internal Medicine, section on gerontology and geriatrics medicine, and he's currently a tenured associate professor, primarily appointed to the Department of Internal Medicine and secondarily appointed to the Department of Epidemiology and Prevention at Wake Forest University School of Medicine. He is a neuroepidemiologist by training, cross-trained in fields of cardiovascular epidemiology, Alzheimer's disease, and brain imaging at the University of Pittsburgh and Wake Forest University School of Medicine. His research focuses on untangling the relationships of vascular disorders with brain aging, Alzheimer's disease, and dementia. He's published a number of papers in these areas, and has presented nationally and internationally in his research. He has served on the National Institute of Neurologic Disorders and Stroke Council for Alzheimer's Disease-Related Dementias Summit in 2022, and he's currently on the executive committees for the Wake Forest Alzheimer's Disease Research Center and Vascular Cognitive Disorders area. He is the principal investigator as well on several large NIH-funded observational studies and investigates these in multiple contexts. So these distinguished scholars will each get up. They're going to present to us, and then we're going to have a moderated question and answer at the end. So first, I'd like to pull in Dr. Ma. Please join me at the podium and to share your work. And then Drs. Henderson, Lewis, and Hughes will follow Dr. Ma.
Thank you, Dean, for the generous introduction. It's such a great pleasure and honor to be here together with my fellow Dean's Research Scholar, Dr. Hughes and Dr. Lewis, to share with you our research. So before talking about our research, I want to share with you a little bit about myself, my scientific journey so far. So I grew up in China, went to medical school in a city called Shijiazhuang, which you probably never heard of. It's considered as a medium-sized city with a population of about 8 million people. In 2002, I flew across the Pacific Ocean to pursue my PhD in neuroscience at Mount Sinai School of Medicine in New York City, which also has a population of about 8 million people. But here in the US, it's considered a big city. So after my PhD, 2008, I started doing my postdoc training, first at Weill Cornell Medical School and then NYU. As for those who know New York, Manhattan, so this is probably from uptown, Mount Sinai, Middletown, Cornell, and then downtown, NYU. So further downtown and from north to south. And you probably already know my next stop. In 2014, I so glad to come here, Winston-Salem, and join Wake Forest as a junior faculty, started my independent research career and started my lab. I want to take this opportunity to thank all the former and the current members of my lab, and I want to thank all the support from the institution, from the department, from our geriatric section, and our AD center. Of course, also thank all the fund resources. All right, now let's talk about Alzheimer's disease. So when you read the literature of Alzheimer's disease, most often you're going to see two words to describe it: common and devastating. Common because 1 in 3 elderly have Alzheimer's disease or another dementia. And Alzheimer's disease is the most common dementia syndromes. Devastating because, unfortunately, currently Alzheimer's disease is an incurable disease. There's no cure. And if you look at this, this graph from the Alzheimer's Association, so the deaths from many other major diseases, including cardiovascular disease, including some type of cancer. So the deaths from this disease all drop or stay flat. In comparison, the deaths from Alzheimer's disease increased over the 10 years period by 145%. So this is really devastating. Among the many Alzheimer's patients, there are also many celebrities, as you can tell here, from scientists to artists to singers, athletes. You probably can recognize some politicians. So former President Reagan, as shown here, perhaps the most famous Alzheimer's patient in the United States and also in the world. His diagnosis and suffering of Alzheimer's disease, as described in his famous 1994 letter, has become really a very significant milestone of the Alzheimer's history. One of the focus area of our research on the Alzheimer's disease is really to study this disease from the perspective of brain energy metabolism. So our brain is small in terms of its weight. It's only 2% of the whole body. But it's big in terms of its energy consumption. It's more than 20%. What does it mean? So it's consume about 0.3 kilowatts per day for an average adult. That's actually a lot. If you think about that's more than 100 times a typical smartphone use per day. If you ever complain how you need to charge your phone every day. And then, perhaps not surprisingly, dysfunction of brain energy metabolism is known to be linked to a lot of neurological diseases characterized by cognitive dysfunction, such as Alzheimer's disease. This is one of the examples. This is the PET imaging study using a tracer called FDG. So basically to indicate glucose metabolism in the brain. Glucose is the main energy resources of the brain. So on the top, this is the human. Sorry, I keep pointing this. Sorry for the audience on this side. So just it's hard to use the mouse here. This is again, so the PET imaging, and you can see the scale. The red means that high energy metabolism, and towards the other side, the gray and the blue, that's the low energy metabolism. You can appreciate that probably compared to the CU, which is cognitive impairment, which is the healthy control, there is a reduction, there's a reduced energy metabolism in the MCI, mild cognitive impairment, which can develop into Alzheimer's disease later on. And there's a further reduction of energy metabolism in the Alzheimer's patients. Similar study has been shown in this rodent model of Alzheimer's disease that there's also age-dependent reduction of energy metabolism. So one of the key players in regulating energy metabolism, in regulating brain energy metabolism, is this molecule so-called AMPK, or AMP active protein kinase. So how does it work? So AMP is a sensor, as I put here. So this is really the sense to sense the energy status in your cell, in every single cell. There's AMPK. I would like you to think about this as a thermostat in your house for the AC system. So you set up an optimal temperature in the summer. For me, it's 73. For my son, it's 65. So now he's back from college. We need to fight and negotiate what's the optimal temperature in the house. And then when the actual temperature in your house is either higher or lower, for whatever reason, then you set the optimal temperature. So the thermostat is going to sense that, going to feel that, and going to tell you AC system to work, either to keep working or stop working to bring the temperature to the optimal temperature. And this is exactly what AMPK does for your cell. So when you have a lot of ATP consumption, which means that your energy state is low, AMPK is going to be activated. On the other hand, when you have a lot of ATP generation, when the energy state is high, so the AMPK is going to be inhibited. So again, this is a really important mechanism to control your energy status, like the thermostat. Without giving too much details about our research, so we found that in the Alzheimer's disease, the AMPK signaling is disrupted, is impaired. This is the oversimplified model, of course. But let me just point to this cartoon showing that in the normal aging, usually there's a balance between these two isoforms of AMPK, AMPK alpha 1 and AMPK alpha 2, so that the energy balance is kept. It's okay, no problem. But in the Alzheimer's disease, somehow, one of the isoform, AMPK alpha 1, we call it, the protein level of this AMPK alpha 1 is abnormally elevated, is super high. And then this balance has been disrupted. So the thermostat is not working, it's broken. And you can imagine how it's going to mess up your house, the temperature. Right? With this, we have this hypothesis that this perhaps is one of the key drivers, is one of the key events that trigger Alzheimer's disease. This could be potentially a therapeutic target for this devastating disease. So how to prove this? So how to prove that our hypothesis is right? We first start with the animal study. We use this genetic approach to reduce AMPK alpha 1 isoform in this transgenic mouse model of Alzheimer's disease. Like I just said, that AMPK alpha 1, this isoform in the Alzheimer's disease brain is particularly high. So we want to bring it down. We thought that too high is not good. We want to bring it down. So we use this again, so transgenic mouse model. So the way we did it, that we crossed this Alzheimer's mouse model with Alzheimer's mouse model, with a unique mouse model we developed in the lab, with a particular reduction of AMPK alpha 1. And we generate so-called double mutant mice. So basically, this double mutant mice means that there's Alzheimer's there, but on top of that, there's a single mutation that brings this AMPK alpha 1 isoform down. So again, that's the point. We want to see whether this is helpful for the function of the Alzheimer's disease. All right, this is probably the only data slide I'm going to show you today, so please bear with me if there's too many jargons. So this is a widely used behavior test to measure the learning and memory, the cognitive function of rodents, called Morris water maze. So pretty much this is just a pool of water. So you put a mouse in the water, the mouse is trained to find a hidden platform using the visible cues. And this is the actual data learning curve. So as you can tell, for wild-type mouse, a normal aging mouse, so the open circles, you can see that with days of training, there's 5 days in total, the escape latency, which means the time it takes the mouse to find platform, becomes shorter and shorter, which means they learn. Their memory is fine. They're cognitively normal. Compared to that, if you look at the black squares here, so this is the TG mice, this is the Alzheimer's mouse model. So you can see that the curve is pretty flat, which means that their learning memory, their cognitive function impaired. And I want to drive your attention to the middle one, the green one. This is the double mutant mice I just mentioned to you. Again, so the Alzheimer's mice, but with that single mutation of this AMPK alpha 1 isoform, bring it down. You can see that the performance perhaps is not as good as the wild type, but it definitely significantly improved from the Alzheimer's mice. By the way, I want to mention that this is done by a former graduate student, Hedina Zimmerman, and we published this study before. I just have 2 more slides, I think. I want to just use this short video to further illustrate my point. So I hope it works, I would say. So this is the last day, the day 5 of the Morris water maze. Like I just said that, at this day, for normal wild-type mouse, it should find the platform, which is hidden, but Helena put a circle here to label it. Should find this platform pretty easily, usually around 20 seconds. But let's see what happened in the Alzheimer mouse experiment. Okay, I'm glad it works. This is Helena, put the mouse into the water. So you see the mouse start to search for the object, I hope. So you can almost tell, if you have done this before, this mouse is lost because the platform's here. And maybe it remembers something. Just miss it. Okay, so meanwhile, let's see what happened in that double-mutant mice with the Alzheimer's mouse model, but with that single mutation. This is the same Helena, same pour water, put the mouse in the same positioning. You can almost appreciate that the searching strategy is different for this mouse. Perhaps not as good as a wild-type mouse, but it's definitely much better improved. There you go. Found the platform, being rescued. So, and that was still struggling. See. In his famous 1994 letter, Reagan announced his suffering and the diagnosis of Alzheimer's disease. I'm always impressed by what he wrote in the last part. So he said that, I now began a journey that will lead me into the sunset of my life. I know that for American, there will always be a bright dawn ahead. 10 years after this letter, Reagan died with Alzheimer's disease. Now in 2025, 31 years after the letter, we still have not found a cure. But we're not in the dark either. Over the past few decades, especially over the past 2-3 decades, we have learned a lot about this disease. And I truly believe that we're close to find a cure more than ever. This is the first Alzheimer's work I participated more than 10 years ago in Tanglewood Park, I think, when I first came here. I like this picture because this really shows how we fight the disease together. Men and women, boys and girls, babies and dogs. So together and we are stronger, right? Let's fight together. And I think we will see that bright sunshine at some time point. Thank you all.
All right, well, hi, everybody. That was an amazing talk, and it's always so cool to see what my colleagues are doing. I'm a little jealous of the mouse videos. All right, so thank you guys for sticking around for dinner time to hear about all of the research that's going on here at Wake Forest. I'm going to talk to you a little bit about some of the work that my group is doing around treatment for obesity. So tonight the focus is really much about looking forward, but I want to for a moment just look backwards and think about where we started with this disease not too long ago. So if we look back to 1960, at that point only about 1 in 10 American adults was obese. Only about 1 in 20 children had obesity. Fast forward to now, we're at the point where about half of American adults have obesity and 1 in 5 children. And this has happened really across all sectors of our population. And in North Carolina is no exception. About 45% of North Carolina adults have obesity, and 10% of North Carolina adults have a more severe form of obesity. So during this time, during these past few decades, as this has been going on, there have been a lot of people like me that have been working really, really hard to try to change this, right? And primarily it's been focused on preventing obesity or treating obesity using lifestyle change, so diet and exercise, promoting that healthy lifestyle. And despite all of that work, we've continued to see this epidemic take place. So what does this mean for our patients? What are the impacts of this? Obesity is linked to so many different diseases, and as a result, at the individual level and at the population level, it has an enormous impact on our healthcare system. So just in the past 2 decades, we've seen a tripling in the rate of obesity-related cardiovascular deaths. We've seen a twin epidemic alongside of obesity of type 2 diabetes. We know that obesity increases the risk for diabetes by 7-fold, doubles the risk of sleep apnea, doubles the risk of hypertension. It increases our risk of 18 different types of cancer. So all of this adds up to a lot of medical care, right? And a recent study estimated that it costs about $170 billion a year in the United States just for the excess medical care related to the obesity epidemic. So when we talk about treating obesity, which is what I get to do in clinic every day, historically, we've really been sort of stuck between, on one end of the spectrum, lifestyle interventions, low-calorie diets, physical activity, and on the other end of the spectrum, we have bariatric surgery. So lifestyle interventions, while they are in some ways easy to deliver, they don't result in that much weight loss. So typically what we see when we do this in real clinical settings is on average patients lose about 3 to 5% of their body weight, and they don't really keep it off. Once the lifestyle intervention is done, people tend to regain their body weight over time. On the other end of the spectrum, we have this incredible tool called bariatric surgery, which is the most effective treatment that we have for severe obesity. Patients lose anywhere from 20 to 40% of their body weight, right? But a lot of people don't qualify for surgery, and even those who do, many people don't want to have surgery. So we're left with this sort of big gap in the middle, right? And unfortunately, that big gap in the middle is where all of the action takes place in terms of health benefits. So much like with high blood pressure or diabetes, where there's sort of a number we have in mind, right? We want to get your blood pressure to 120 over 80, where we start to see all of these amazing health benefits accrue. The same thing is true for weight loss. If we can get patients into this zone of 10 to 20% weight loss and keep them there, we're going to start to see improvements in all of these other things that I just mentioned, right? So this is really the sweet spot. But historically, we have had nothing that can really do that at scale. So how do we do this? How do we get more of our patients into this zone and help them stay there? If you have looked at a newspaper, watched television, listened to NPR, anything in the past 3 to 4 years, you might have heard something about some new medications that are coming out, right? So I am really excited to talk to you guys tonight because I think these medications are a symbol of what's coming. This is the potential scalable solution to be able to address the obesity epidemic. But with all of this excitement, there's been a lot of demand and a lot of interest. And I think health systems, I think insurance companies, private insurers, our public insurers like Medicare and Medicaid, our government, are really sort of reeling and trying to figure out how do we deal with all the demand for this, right? And despite really exciting clinical trial results, despite the demand, what we see when we look at real-world data is that very few patients are actually taking these medications as recommended. So if we look in electronic health record data, if we look at insurance claims, we see that only about 5% of patients who are eligible for treatment when one of these medications actually start one. And especially for the newer medications, the semaglutide, the tirzepatide, over half of people who start will stop taking that within about 6 to 12 months, even though it's recommended to use long-term. Why is this? Lots of different reasons, but one really important one is that most patients don't have insurance coverage for these medications. So it's not required by law for private insurers to cover it, and our public insurers right now have very poor coverage for these medicines. And when we start to think about the cost, especially for the newer medicines, they're really quite enormous. Some patients are looking at close to $1,000 a month for these medications. And if you think about doing that long-term, indefinitely, it really becomes unsustainable for the individual patient and certainly for the healthcare system. So we're sort of at this really exciting time, but I think also a time where there's a lot of really big questions about how do we actually use this new, really exciting resource in a way that's responsible, that doesn't bankrupt our healthcare system, and that helps the most people possible. And so there are a number of big questions that I have, and I know that a number of researchers at Wake have about this. And this includes things like, what other health outcomes do these medications improve outside of obesity, and at what cost? So things like Alzheimer's disease. There's been some really interesting early work looking at these new medications and whether or not they can help prevent cognitive decline. Who's going to respond to which medication? Does everybody need to be started on semaglutide or tirzepatide right off the bat? Or might some patients actually respond to a less expensive generic medication that could be used first line and help to save a lot of cost at a health system level? Bariatric surgery is still there. I think we really need to do some research to understand how it fits in this new picture where we've got medications that actually can produce close to the amount of weight loss that historically we were seeing with bariatric surgery. And then something that my patients ask me almost every day is, do I really have to take this forever? I don't really want to be on this medication for the rest of my life. What happens if I stop taking it? So are there ways to support our patients who want to come off of these medications, or our health system who doesn't want people to stay on these medications forever, with lifestyle change or maybe a cheaper medication? So I am super fortunate to be working on a couple of active studies right now that are trying to answer some of these questions. And I'm collaborating with amazing faculty members here at Wake, and we have an amazing staff team that really makes this happen. So one of these studies is the LEAP study, and this is a large clinical trial funded by NIH, looking at the long-term safety and effectiveness of a generic medicine that's been around since 1959, but was only ever approved for short-term use for weight loss, called phentermine. It's about $5 a month. And so we've worked with health systems across the country, so we also have sites in Southern California, Texas, and Minnesota, and have recruited almost 900 adults, half of whom are taking a placebo pill and half of whom are taking active phentermine, and we're following them for 24 months to look at the safety and effectiveness of this medicine. And our hope is when we get our results, I'm blinded to the data right now, so I have no idea what's happening. I just have to wait and be patient. When we get our results next year, either way, it's helpful, right? Because if this drug looks like it's safe and effective for long-term use, this could be a really important first-line agent to use at a population level and help reduce some of the costs of treating obesity with pharmacotherapy. If it doesn't look like it's promising, then we can stop having insurance companies require this as a first step, which many are. And places like Mass Medicaid now requires that patients take this medication before they get access to the newer medications. So we really need an answer to this question. Another exciting project that I'm working on with colleagues in Boston, also funded by NIH, is leveraging this idea of big data and real-world data, which is something that I'm passionate about. So we're taking a large nationwide commercial insurance claims data set that contains information on millions of adults, and we're looking at what's actually happening when people take these medicines out in the real world. And we're going to compare all of the different FDA-approved meds to one another to look and see, what is their impact on total health care costs? What is the impact on things that patients care about, like hospitalizations, emergency department visits? What happens to patients with diabetes? Does their diabetes get better? Does their hypertension get better? What happens to risk for events like cardiovascular events like stroke or myocardial infarction? And just starting to put together, our groups of users in this data set who are starting these medications, we're seeing some really interesting trends. So this is just showing you in thousands of people, the number of people every year that are starting one of these new anti-obesity medicines in the United States from 2014 to 2023. And what you can see is that blue curve on the top represents generic phentermine that I just told you about, this oldie but goodie generic medication that costs $5 a month. And you can see even with other new meds coming online during this time period, it has really remained the most popular medication that we have in our arsenal because it works for a lot of people and it's cheap. When we start to look at semaglutide coming online, this is a really, really dramatic change. And you can see semaglutide for obesity was approved in late 2022, and it's the purple line there, and you just see it dwarfs the rest of these. All of a sudden in 2023, the scale of the y-axis is completely different. All of those other drugs are way, way down at the bottom, and semaglutide has surged. And so when you think about what is this showing us, people are really wanting this medication. And it is a very expensive medication. And I think what's happened in the years since this is insurance companies are saying, nope, we're not going to cover it anymore. We can't, because there's been this huge rush. And so we really desperately need answers to questions about cost effectiveness, first-line therapy to help guide policy. And Dean Boulware mentioned a lot of this already, but I'll just close by saying that I'm really excited to be where I am doing this work, because I think we are in an ideal position at Wake Forest and an advocate more broadly to really be leaders in this space internationally. If you look at where our patients live in the United States, in our health system, we are in some of the states that are most affected by obesity. And so we need to do this for our patients, right? And at the same time, with the size and scale of the system that we now have, we can do the kind of research using our data that gets these answers efficiently, right? So we have data on millions of people now with our electronic health record. And with some of the recruits that she was just talking about, we have leading experts in the world on using big data to do research. And now we have the data too, so it's very exciting. And then with the National Center for Clinical Trials coming online, I think, advocates should really be near the top of the list when companies are looking for new places to do clinical trials. And I think, the next 10 to 15 years in this field are really gonna be incredible. There are something like 100 new medications that are in the pipeline right now, following in the footsteps of semaglutide and tirzepatide. That is just the tip of the iceberg. So things are gonna change. Even though they've already changed a lot, they're gonna change even more dramatically in the next 10, 15 years. And I think with NCCT and with our patient population, we really should be raising our hands and be at the front of the line to be able to provide these treatments to our patients. So thank you all so much for sticking with us, and I'm excited to chat with you in the Q&A.
Good evening, everyone. I'm Tim Hughes. I'm your final speaker for the evening. And as Dr. Ma mentioned, your brain is kind of like a cell phone by this point. I hope you have a couple bars left before you need to recharge. So I'm here to talk to you today about a topic that actually relates to both of the speakers that have discussed earlier. My area of interest is how we prevent Alzheimer's disease and related dementias. What can we do now to change the course so that we can eliminate dementia, at least for some people, if not for the majority of cases? So what I want to do is start with a few takeaways. If you don't remember anything tonight, these are the things I hope you have, okay? The first is Alzheimer's disease is not as simple as you read about. Plaques and tangles, that's all that matters. It's actually more complicated than that. It's a multifactorial, many causes, chronic disease that develops over years and decades. What does that mean? That means we can do something about it as it's starting. The next piece I want to share with you is a bit unique. My area of interest is in how vascular disease that we develop in our body migrates to our brain and contributes to dementia. And then, what can we do about it? How can we target vascular disease to reduce our risk of ever getting dementia? All of you are familiar with dementia to some extent. You read about it all over the place. Dr. Ma showed how the number of deaths are increasing. The number of cases are increasing. Actually, a little secret is the number of new cases per 100,000 is going down in every developed country. Why? We actually don't know. We're doing something right already, and we don't know what it is. I think it's because we're decreasing vascular disease, and I'm going to show you why I think that. There are many different types of dementia. The classic idea was dementia is an umbrella term, and there's Alzheimer's disease, the number one cause of dementia. And then there's neat little buckets of these other things like vascular dementia, Parkinson's disease. That's all actually too clean for the real world. When you look at people who develop dementia and look like they have Alzheimer's disease, only less than 20% of them actually have pure Alzheimer's disease of just plaques and tangles. That's not what you've heard about. What you haven't heard about is that the vast majority of people who have dementia in later life have a mixture of vascular and Alzheimer's disease pathology. It's not pure. So just targeting Alzheimer's disease may not be the thing that prevents the disease in most people. So what does this look like? When I say vascular disease in the brain, what does that look like? Our arteries change as we age. We've heard of dementia. Back in the old days, it used to be called hardening of the arteries, right? There's actually some truth to that. Here's what happens to our vessels in our brain as we age. You'll see this loose group of cells in the far left. That's what a normal arteriole, the smallest arteries, smaller than a hair, that feeds every neuron in our brain. That's what it looks like when it's normal. As we age, it thickens. The diameter on the inside reduces. There's less blood flow getting to our brain. There's less ability to carry that glucose, that's our primary fuel, along with oxygen, to those areas of our brain that need it the most. It also shows itself in different forms of vascular lesions in the brain. These lesions can be routinely found on brain imaging, like MRI. And these are called small vessel disease. There's things from small strokes to white matter disease in the brain, to enlargement of perivascular spaces, and to small microbleeds that are in the brain. These are all those things that add up to that 70% of probable dementia cases that I told you about. This is what's happening. Well, the way that we've done this for many decades, get an MRI, and a neuroradiologist sits in a dark room and will read these things, and they're looking for what they're expecting to see. They're not looking to see if these things are there unless they expect to see them. So we have worked together with colleagues using things like artificial intelligence and machine learning to actually identify these lesions at scale. We can now do this quickly on hundreds and thousands of images. That makes it available to studies where we need to understand these vascular contributions to dementia. So what does it mean when we're talking about this? What does this look like? We've done lots of research in big observational studies, many of them right here at Wake Forest School of Medicine, where we have looked at things like blood pressure and the stiffness of our arteries to see how that changes the flow in the brain. For somebody who has nice, healthy arteries, they have nice, elastic arteries, they've got a good blood pressure, things are looking great, they actually have a pretty nice looking brain, okay? You'd look at it and say, it actually looks younger than you would expect. As our arteries stiffen, as our blood pressure increases, we see more small vessel disease in the brain. We see more Alzheimer's disease in the brain. We see more of the overlap of these two things, just like I said, are the primary cases in the brain. This is happening with people with more poor arterial health. So here's the way we take this. We're moving just from the fact of hypertension's important, we've got to treat it. Now we're studying the paths that all of these vascular factors impact our brain, from the upstream risk factors, to the way it changes our arteries, to the way it shows up in the brain as vascular disease in the brain or Alzheimer's disease. And ultimately, what type of dementia is somebody likely going to get based on the type of imaging abnormalities they have? So we're in particular interested in targeting vascular disease to prevent dementia, and I'll show you how. Many of you may be familiar with the SPRINT study that was run here out of Wake Forest. There was a mind component to the study. Okay? Some of you may have actually been in this study. The idea behind the study is if we treat blood pressure aggressively, getting people down to a good blood pressure below the standard was 140/90. Get them down to 120/80. Aggressively treat that blood pressure. What happens? Well, if you aggressively treat, you lower blood pressure. On average, 13 millimeters of mercury different. People's blood pressure dropped by that much in the study on intensive treatment. Well, what happened? Less cardiovascular events, less death, and less dementia events, less mild cognitive impairment when you put them together. Okay? So aggressively treating blood pressure. This was the first study to show that if you treat blood pressure aggressively, you can prevent new cases of cognitive impairment. This was remarkable. There's yet to be an Alzheimer's drug that does this effect size. It also reduced the amount of vascular disease in the brain. That white matter hyperintensities that I told you about, it reduced the progression of those over time. We were really interested in what did this actually do to the arteries when you lowered the blood pressure? What we found that in the sample that we had really detailed measures, the blood pressure dropped by 15%. The amount of blood pressure on our arterial walls, the force that it puts on the wall, decreased, but something that didn't change is the innate stiffness of the arteries. As our arteries get stiffer, that predicted future events, regardless of whether people were treated. So there's a very large piece of arterial health that we've been missing just by focusing on blood pressure. That's led to new studies like a clinical trial that we're doing right now that's entering its second year and its final phase of visits. In this study, we're using something that people often eat, soy, but most people don't have the right gut microbiome to make the beneficial thing called Equal. This is now something that people can take as a dietary supplement, and Equal has been shown already to reduce arterial stiffness over 12 months. We're looking to see if it will do that over 2 years in a randomized trial to provide real evidence that this improves arterial health. Then we'll see if it reduces the amount of white matter hyperintensities in the brain, slowing the progression of vascular disease. And then also we're looking to see if it will slow cognitive decline over time. So what you've heard about is how we've taken things from observation, new targets like vascular health, how we are taking them to clinical trials to find answers that can scale up in a system like ours. So we need new approaches to find new targets and treatments to prevent dementia. Because if we can prevent just 5% of dementia cases, what we actually do is prevent 50% in 5 years. Differentiating dementias means personalized medicine. There are now blood biomarkers that are available for people to understand whether or not they have the proteins associated with Alzheimer's disease building up in their blood. I've already told you that's one part of the story. We also need to be thinking about integrating imaging routinely to say, how much vascular disease is there? Is there something that we weren't focused on that we can treat and prevent vascular disease to prevent that dementia? When we pair imaging and biomarkers together, we get to personalized medicine. We know if somebody needs one of these new Alzheimer's therapies, and possibly do we need to treat their blood pressure as well. And finally, this type of work needs big groups. So I'm fortunate to work with very many different institutions and researchers interested in this topic, where we're looking at treating vascular disease. And something that we need to develop in the future, like we have networks for Alzheimer's disease drugs, are networks for treating vascular disorders so that we can prevent dementia. This is a new area that's gaining a lot of traction. Even the criteria to diagnose Alzheimer's disease now includes vascular in the mix. So we're working to generate new groups and research strategies to do this. And this type of work takes huge groups of people, many institutions, and I'm very fortunate to work with a lot of those individuals, and very fortunate to be in a place here where we can take things, where we can take it from observation to clinical trials and then scale it up across the health system. And with that, I'll thank you for your attention.